Nice. So happy, Markus, to see you again after 1 year, more or less.
Yes.
So happy.
I'm also very glad.
I'm following your documents in the internet, your webpage. This document for me opened a new door in after 15 years teaching Prolog. Open a new door to access to exercises that before was almost impossible to solve, like Sudoku or another similar exercises that I had many problems with trying to use codes and at the end never worked good. And with your implementation, we did this year with my students, so great, so smart, so efficient. I'm following your material and I want to improve, to go ahead and see more exercises in the future. So happy. This is like, I don't know, a new door to knowledge thanks to your webpage.
Great. I mean, this is really nice to hear, and I'm so glad that you find this interesting, and also your students find it useful. Hello, everyone. I'm extremely pleased that you can use this, and I mean, it's also great, of course, that you all have such a dedicated teacher. I mean, this is not normal even, and quite unusual, in fact. So that you are really on the edge, also on the things that are now getting interesting. So these are exciting times, because this is also the first time that now free Prolog implementations are becoming so available even. I mean, this is highly unusual. I mean, in the 80s, for example, the first Prolog systems, you could buy them for tens of thousands of dollars, and even also today that the commercial systems cost tens of thousands of dollars, and they have no problem selling it at that cost. So there is a market for that, and but now for the first time, also due to the internet, the free implementations, and also due to better implementation techniques, and also maybe interest from more people, and also new programming languages, of course, that are maybe more maybe faster to implement Prolog systems. I mean, it's you must also take into account implementing a Prolog system. It takes 20 years easily. So the systems we are now seeing, they have all been under development for 25 years at least. So this is especially maybe for students interesting, because I mean, probably now at 20 or 25, it's hard to imagine that someone has started working on the systems before you were born even, and they are now still progressing and getting better. So this is completely new, maybe also a phenomenon that things that take so long.
Okay. I want to tell to my students, if they want to make any question, you can do. Don't worry. Probably I have some question I want to ask to Markus, but if you have any question, please don't hesitate to make your question. Markus, I want to make a question to you. Like, do you think we are at a different point, a new starting point in artificial intelligence, thanks to this new way to program, like constraint logic, this constraint logic programming? You think we are in a special point in the history of artificial intelligence? Do you think that will open new doors to resolve more problems than before, or?
Interesting. I mean, a highly interesting question. I think personally, yes, in a sense, we are in a new place now. Even though many methods that are now becoming available were already known for 20, 30, 40, 50 years ago, they are now becoming feasible because we have better, certainly better hardware. But not only that, we have this. I mean, it sounds ridiculous almost to say it, but we have now the internet, which wasn't available in the 80s. so that so much interest, also so much publicity. I mean, also in the 80s, certainly there was a lot of publicity, but now you have the opportunity to reach, to really reach the best programmers and most interested mathematicians and implementers, most dedicated people also to work in this area, which I think is highly unusual, that it becomes at the same time first so decentralized that I mean a single person can nowadays start an entire currency which is then used worldwide, completely unheard of, but in a sense also becoming so highly centralized that maybe 1-2 companies or organizations can summon implementers from all over the planet to work on one specific area, for example, with almost unlimited funding. So I think both situations, that we have this extreme centralization and also being able at the same time to reach into the farthest areas of the world to gather interest in these topics is both extremely unusual and unheard of and unprecedented. So previously, I mean, to work on the cutting edge, you have to be at a university almost, or maybe find some highly specialized areas where you could apply this, which were much harder to find. Now it's quite easy to find people who are working on this, apply or show the work you can do, and immediately almost work in that area, which I think is unprecedented, and I think this is one reason also why we see such extremely unusual developments suddenly, because you have, I mean, there's some competition, some team wins the competition with some approach, and the next day the entire world knows it. Everyone in that area knows it and can apply it, can build on this. So, I mean, if you also look at the Prolog systems that are now becoming available, and the free systems especially, contributors from all over the world can work on them. And it's almost normal to get a different pull request on GitHub from a different continents all the time. So I think this is extremely unusual, unprecedented. So I mean, in the 80s, certainly the 5th generation computer science systems project also was so ambitious and also attracted a lot of interest and also attracted these experts, but lacked these international connections that you could immediately work from anywhere on the world on these projects and contribute. And this is now the normal situation. So
okay.
And also I think one thing also, I mean, the problems are also the problems are becoming harder simply. I mean, we need, I think, also the consciousness that we need simply better tools, also better languages, better ways to implement software is also becoming increasingly obvious, because we have also now so many legacy systems, which is also unprecedented. I mean, almost tautologically, it's unprecedented that we have such a long history of legacy systems in banks, in airlines, in the government sector, in legal tech. So we have all these legacy systems also now, and we need to really continue working in these areas, or keeping these all these sectors working. I think it's clear that we need better mechanisms to develop software.
Yeah. In this sense, neural networks are deeply used in the industrial education and research. But you know, neural networks have the problem. You don't have a way to know how it's like a black box system where you train the net. At the end, you obtain good results at this point, but you don't have a way to know exactly what is happening inside this black box. And system like Prolog with logic can give an artificial intelligence with the opportunity to change this model easily. For example, I found your implementation of this timetable for the school. I found this so great so efficient. You can schedule a big 16. I think your example you have, your third example is 16 class. I was secretary in my department. I had to organize this classroom. It's really hard. It takes a lot of time to make an organization with taking into account this conflict with this the availability of the teacher professors. It's very hard, and you get this system in only less than 1 second. You organize everything with all the restrictions you want. It's very easy to add new restrictions. It's simple if you know how the system works. It's very easy to add your own restriction in your system. It's very easy to modify. What do you think that way to implement with constraint logic programming? In which sense would be better than neural networks? In this sense of what give more?
Yes. I mean, first of all, it's a really interesting task. This also, me personally, I was extremely attracted to school timetabling, even at school already. So this is one thing that also attracted me, because I, as a pupil, I always wondered how do they create these timetables. I mean, also at our school there was one single person, so your analogon in Austria did this also manually. I always wondered how they did this, and for me it was a revelation to see that this can also be easily done with constraints. And I think here it's pretty clear that there is nothing to guess, but the constraints are already known. So you know that some teachers have this preference. You know already, because they tell you. They tell you, I want to have Wednesday free always, because in our school, for example, they could choose one day in a week where there would be no schedules, no lessons scheduled on that specific day. So you know this in advance. So there is nothing here that you don't have to go through the effort to learn this from existing data, for example. So it would be kind of pointless to go to train, for example, a neural network to find out that one of the teachers has this preference or wants this day free. It could also be different this year, for example, than other years. And it's pointless to go through the data to conclude this, because you can easily ask the person. You can easily go to the teacher and ask which day do you want free, and then try to find a schedule that satisfies all these requirements. So this is, I think, a clear case where the constraints are known and need not be guessed. And this is one example of such a case. There are many other such cases where we don't need to guess the laws from the data, because the laws are already available. So, for example, in legal tech or in tax law or in government applications, you can simply go through the laws and you know what rules must be satisfied. You know, for example, there is no question or no need to deduce how a tax could be computed from some data, so, and don't need to train a network, for example, to guess what percentages maybe have to be given to the government because this is a tax on something. I know these rules. I mean, maybe I don't know them, but I can look them up. They are written in law, and them. And I mean, especially in government applications, there's a clear law even that the administration can act only insofar as the law grants it. So the administration cannot act arbitrarily, but must also uphold all these laws, because the administrative acts must be computable in a sense, or must be traceable. So these are clear applications, I think, where it's more interesting and more important to think about how can we convert these existing known rules into programs that can run automatically. And I mean, this is also not unusual. This happens all the time, also in government applications. Every time you log into a government system, there is something that happens automatically. And if you have, for example, a text application or a text filing, there is some computer program that maybe makes some checks or assessments. This all already happens, but it's maybe not as elegant currently as it could be, and not as transparent as it could be if these rules, for example, were written in a more readable, more easily verifiable way. So for me, one critical aspect of Prolog is that you can really also reason about the programs themselves. So you can simply read the entire programs, make some checks, make for example type checks, or interpret them in different ways. Maybe try to find out whether they correspond to something from previous years and so on. So this is one, I think, a quite clear example where you don't have to guess anything. It's all known. The task is only how can we automate the things we want to hold.
Yeah, and it's very easy to modify the model, deleting some rules, adding some new rules or new logic. Not only rule, but you need to implement a new simple predicate to modify the model. It's very simple. If you have a neural network, you have to train again with probably, I don't know, probably you have to change totally the model. But in this way, you have this logic easily understandable for a human, no? It's so interesting. Can you talk? You tell me you have a new project with oncology.
Yes. This is one.
Can you tell us a little bit about that?
Yes, certainly. So this is also quite recent for me. There's one oncologist, so a clinical oncologist. He has a medical degree and also a mathematician. So he has also a mathematics degree. I post his homepage in the chat. It's Precision Methods Guru. I hope you can read this. This is David C. Norris. And so this looks quite tough. He has lots of papers also and publications about his approach. Also some videos if you find them interesting. But so there are several things here to mention or to read. But one thing I would like to mention specifically in this area is a new package he's currently, in fact, working on called Precautionary. And let's I send you this GitHub link because this is really work in progress and uses, in fact, also new features that are just now becoming available in SWI Prolog, for example, to make this more efficient. I send you here the link also in the chat, this precautionary package. And specifically, and this is the bleeding edge branch now, this is the third link I post, this BOIN CPE. And now we are really at the heart of the matter. This CPE stands for complete path enumeration. And the use case is this. When you are in drug design, this is, for example, in chemo or in some therapeutic methods, when you have cancer, you get some medicine, and the point of this medicine is to try to kill the cancer. And for this, you have to use as highest dose as the patient can tolerate. So this is the maximum tolerable dose, and then it's toxic. So if you go beyond that dose, it would be toxic to the patient and maybe even kill the patient or have some very severe side effects. So you can't go beyond a certain threshold because then it's too toxic. But you must titrate it right to the limit that the patient can still bear. And how do you find this dose? I mean, it's if you have only one patient, it's in a sense straightforward. You just give more and more medicine. But if you do it in that way, it can also have adverse side effects because the patient, for example, develops some tolerance if you start with small doses. So you ideally also have to start with the highest dose that can be tolerated, but it's hard to guess. So here statistics enter, of course. So there are some clinical trial designs where they find out or try to find out which doses can usually be tolerated at most. And this thinking in itself, this statistical thinking, also comes with problems and caveats, of course. But the point is that to find out these doses, because the pharmaceutical company cannot simply sell the medicine and tell the physicist, just try it out and just go higher and higher. They must specify some initial dose, for example. So it will all must have some basis in some trials, for example. And in these trials, so you have, for example, 100 patients, and there are now various methods in which you could try to detect or find out or reason about what the maximum dose is that can be tolerated. And this works like this. You, without going even with the caveat that I'm not a physicist, I'm also certainly not an oncologist, but what I understand from these trials, as far as I know currently, is that there are various trial designs in which you could approach this task. But one commonly applied method is the so-called 3+3 design, where you enroll 3 patients at some dose, in the initial dose, so level 1, so to say, and then try it out. And if they can all tolerate it, then you forget these 3, you enroll the next 3, and you go higher. You go one higher. And then there are various possibilities. So, for example, 1 can no longer tolerate it, then you forget these 3 and enroll another 3 with the same dose. Then if they can all tolerate it, you can increase it. If you have, again, one severe side effect, you must stop at the dose. So the exact details depend on the trial design, but the point is to get some feeling or some idea of what the maximum tolerable dose is for this specific medicine or drug. And now the point is that you can make several statements about the trial design itself without even applying it, without even running one specific instance. You can analyze the trial as a whole and say, for example, is this a good way to find out the maximum tolerable dose? Is this a good way in itself? Or would it, for example, not be better to enroll maybe 4 patients or maybe 2 patients and then make some different things? And this is the point of David Norris's current work to apply Prolog to the trial design itself. So to formulate the trial design in a declarative way, so that you can, first of all, run it, apply it in individual cases, but also reason about the trial design itself and ask, for example, and this is complete path enumeration, to generate all possible trials that can occur as a result of this specification. And this is where Prolog comes in, because he describes the essence or the rules that are applied depending on what happens, depending on whether you have, for example, 0 adverse effects or 1 or 2, then you either stay or escalate or de-escalate. So the point would be, of course, to unify all these possible trial designs themselves via this formal mechanism, so that you can use Prolog or this domain-specific language he is working on to say something then about this trial design. And I think this is an extremely interesting task, first of all, because it clearly has some health benefits, and it's in fact applied also currently, and can also maybe ensure safety properties or help us to automatically determine safety properties of these trials themselves, so that you can say something, make some statement. For example, we have looked at all possible trials that can arise, all possible concrete things that can happen at, for example, a drug that has 6 different dose levels, and we have concluded that something never arises. Some case where, for example, there is some redundancy in the trial design, so that you could, for example, avoid that too many patients get an overdose. So this is, but this is just now beginning. So this is work I've also only for a few months cooperated with David and helped in some ways, in some small ways. David is working on this, and I, for example, my task here is to find out if CLBZ, so this constraint solver over integers, maybe can be improved in some ways. If David mentions that there is some cases where he sees that it's slow, so I can look at the code and think, okay, maybe I can make it faster for some use cases. So this is my small contribution to this work. Yeah, but this is something I hope also your students find interesting as some concrete application and very recent application of new methods, also of new constructs that are now becoming available for the first time in SWI Prolog, and it could be very interesting. Certainly, if some of you are interested, then also to continue maybe in bioinformatics or oncology or medical designs. This could be also maybe an interesting practice project.
Yes, I'm not sure if I understood everything. I'm not sure, but would it be possible in this model, for example, including information about, for example, the age of the person that have this intolerant? You can include to the model information about the age or the weight, or if you have previous, for example, as habit like never do a sports or something like that. You can include this type of rules to the system to add information.
Yes, I mean this is one now also already the another interesting question. There are also, and I just must mention advice, medical advice, but as far as I understand it, also in the medical community, you have oncologists who argue that you must really treat each individual specifically, because each of them has a specific condition or specific age, of course, a specific situation, hobbies, and so on. And you must, for example, some would probably argue that you cannot apply this statistical reasoning because the patients are all different. And even if you have, for example, 1,000 people who can tolerate the drug at this level, maybe then your concrete patient still has an overdose or still doesn't tolerate it at that level. So you must, they would likely argue, you must really apply your attention to this specific patient and go into all these details. And certainly all these factors come into play then. So one point of all this work is also to find ways in which it's easy to see or prove certain properties where one can then show a weakness, for example, in this approach, in this 3+3 design, which I mentioned. So this would certainly be an interesting result and useful result to say, if you do it this way to determine maximum tolerable dose, for example, then you run the risk of something or with some probability, for example, to overdose patients that you then treat. But the point here is just to start from somewhere so that more and more can be automated. Because what's now the situation also in the medical community is there are some textual descriptions of how these trials work. So the trial practitioners, they get these textual descriptions, and in the description it states, you must escalate, you must de-escalate, you must enroll new patients, you must stay at this level. And this is all prone to mistakes and also interpretation mistakes, because the clinician who really applies this or tries to act according to the description may misread the statement, because there's maybe some small footnote that says, if you had one case where you already de-escalated, then don't de-escalate again. And so some maybe exception to something. And it's currently quite hard also for the clinicians to make absolutely certain that they follow the design as it was actually planned or actually intended. Mm-hmm. So one key contribution here also by David is to formalize all these currently informal descriptions as a Prolog program, as rules that can be automatically applied, so that one can show another clinician, these are the rules, are they okay? And if if all of them agree or a significant part agrees and says this is the rule, or unless anyone can, or they cannot point to anything where they say this is not what we actually intended with the design, then you can run it automatically, because these rules are machine interpretable and the computer can execute them. And then you have removed at least this problem where a different clinician interprets the rules in a different way, because then it's clear from the description what must be done at each step. And if not, then certainly David's work should also point this out, find it out. For example, here is some ambiguity. This is also another important contribution, because from this declarative description that David is currently working on, you could, with a Prolog program, analyze all these cases and find out, for example, that in some situations, two different branches, two different procedures would apply, because they are not mutually exclusive, or they can both could both be applicable. It would be, of course, also an interesting and useful contribution to either find out such a problem in the specification, or on the other hand, to guarantee or make this strong safety property that this does not occur.
I want to share you one idea related to this question. My father, he had a cancer.
Very sorry.
Yeah, he died in 2015, at the end of 2015. My brother, he dedicated his life to try to study another way to apply medicine, like Chinese medicine, other concept. And there, doctor, I don't remember the name now, but I can give you the book, because he have an idea about the cancer. I think it's very interesting. This approach is for me, it's very different approach. Like he said, that immunitary system is a question not only for one individual, it's a question for a group. It's very interesting to think about immunitary system is outside, or not exactly outside us. It depends on the group. For example, he said that cancer comes to resolve some questions. Like, for example, he said that this person is a very hard idea, okay? I know that it will be very hard for one person that can have this cancer. This person, in a certain way, are not giving the opportunity to people in the group to go up. It's like someone that have a lot of power are not giving the opportunity to group to go up, to develop themselves, or the other people in the group. No, this in this sense is very particular idea. I know it's not possible to apply this idea in any case, but for me it's interesting to try to find if these type of elements will appear frequently in these persons, like. People, for example, in case of my father had for him was very difficult to delegate task to other people. It was very hard to delegate task. Probably he's something like, I don't know, is I don't know, something will be interesting to explore.
Certainly. I mean, this is all, David is a strong proponent also of this patient centricity. So all this work is also meant to find really weaknesses of this statistical approach. Where you treat all these patients the same. So this is the goal is certainly also this individualization, where you can then take into account more that's specific to that person. But I mean, just first, David is not present, and I'm not a medical specialist, so this is only the prolog part that I understand, and then that I try to help. And just I posted it if you are interested from an application of prolog perspective. Maybe one of your students is interested in this, and this is certainly the prospect. I mean, this is certainly in the right area if you want to go into this direction, in the medical direction. There are many other possible applications, certainly. Also in oncology, for example, this also what you mentioned, maybe going through the literature of existing results, or for example, of these combinations of approaches that were already tried maybe in specific situations. These oncologists, they have their databases, but they are not easily accessible for the oncologists themselves, because the oncologists usually are not prolog experts, for example, or cannot write, for example, their own analysis of this huge body of literature. So you can, if you're interested in this work, would be also an interesting project to simply go into there is somewhere where you can download, I think, a 700 megabyte file of for example, documents of drugs that were already tested in combination, also with some other attributes added, and it would be an interesting self-contained project in itself to write, for example, a prolog, a parser, and prolog was designed for parsing. So this was really would be ideal to find out such connections, maybe starting from somewhere, starting from these drugs, and then certainly, as you say, find out more connections, maybe by intelligently processing the data would be a great contribution that I hope helps also in the future, certainly for patients. So again,
I remember the name of this doctor. The name is DAVID LUJAN. I write in the chat. He had these interesting books because he had a lot of experience in Chinese medicine, in India, many places, and he developed this strange idea of immunology in immunology system in the sense of group instead of the sense of individual. I don't know. There are many things. There are many people who say that changing habits in life can improve. Probably, if the cancer is very extended in the body, you need the help of the chemical things, or I don't know. But at the same time, you can do attack this in the different ways.
Yes, that's certainly. This is really also, David mentioned this repeatedly also to me. This is a multifaceted disease with several factors, also a metabolic component so it depends highly also on the patient. And so this is one application that I briefly mentioned, and I pasted these links. And if you're interested, I hope one of your students also, and thank you for this link. Now I see also the what you pasted. Thank you.
I'm gonna, for me at this point, I want to first, it's in this first step, I want to go ahead with your exercises, try to understand your way to program. I think it's very interesting. I want to analyze your code, try to understand how you program, because I think this is so great way. For example, my next point is to try to understand this timetable organized software, because I realized that will be very interesting. Not only to this program will be interesting not only to organize the classroom. You think about you are in a department, and you need to know how many professors you have to contract.
Yes.
Or how many classrooms you need for your school, or if you have enough classroom or not.
Yes.
In using your professor, it's very easy to change the constraint and make some tests. Okay, what happens if I only have professor that can teach in the morning? Or what happens if I put a new classroom, or probably I can teach the same subjects in only 5 rooms, not in 7. I don't know. You can organize, not only planify in one direction. You can give a lot of information using this like a test platform to get new information. It's very easy. Probably it is possible to do the same with this Cáncer approach. I don't know, to know. We know that Prolog have 2 directions. Not only you give the input, obtain the output, and here is it. You have the problem, you can get the solution, but probably you can have different variations in your problem to give information and to take decisions about what to do. It's very easy to organize, planify everything in your classroom with testing some restriction and see what happens.
Yes, I can't. I noticed that I cannot share my screen here. This is disabled. But one thing that also may be interesting, because this what you mentioned, to find out maybe which constraint also is responsible for the failure. This is also very easy in Prolog, and also one key attraction of Prolog, that you can simply remove goals and obtain a generalization. So this way you can, and in SWI Prolog, for example, you have library debug, where you can simply, you don't have to comment out anything. You can simply insert an asterisk, and then the goal is generalized away. And if you know, if you then try it, if you generalize away a goal and run the program again, the query, if it then still fails, then you know this constraint was not responsible for the failure, or could have been responsible, but you know that some other constraint still is too tight. So you must maybe try a further generalization and try to really pinpoint which fragments still cause failure. Then you know that so you can debug the program in a way that maybe fits very nicely with this thinking about what still holds, if this is the case or not, no longer the case. So this is also quite unique to Prolog. So there is no other programming language where you can, for example, simply remove a few lines and then try it, because
it doesn't work.
It doesn't even it doesn't work, doesn't compile. But in Prolog you can do this, which is highly unusual.
Yeah. For me, see, there are some exercises we did. I have no idea how to resolve in other programming language. Really, I don't know. Probably, for example, we analyzed the Sudoku in the 99 Prolog problems. You know this page.
Yes.
The solution in this 99 problem of Sudoku have 236 lines with codes. Very, very complicated to understand. Your implementation are probably, I don't know, 3 lines in the first part, the second predicate another 3. Very simple. It's not only like describe what a Sudoku means. It's only that. So we are only like describing what means a Sudoku.
Yes.
Very easy to change the rules and create a new game, different game. Only changing some rule. It's so smart, clever, and so efficient. No, for me it's a surprise how efficient is this methodology. For me, it's a methodology how to organize the information like as integer and use constraints, because you have both. You have to represent this problem with integers.
Yes.
And then use this constraint, like how you resolve your puzzles, like with integers. This zebra puzzle is very interesting. Go to.
Yeah. This is a great fit, certainly. So these combinatorial tasks are great fits for the constraint solver, and this is really works out in practice very nicely, and also is interesting because you can improve the constraint solver, and all the programs automatically benefit from the improvements to the constraint solver. So this is also quite unusual that you can keep the program in this way and simply find the most elegant formulation, and you benefit from all the improvements in the constraint solver. And you know that this syntax, this will always be there. This predicate logic syntax, this will always be like this. This is very timeless attraction.
I want to ask some students, Alexander, Noster, and Laura, and Adrian. Do you have any question? Do you have any, whatever you want to know? You have a Markus Triska today. Probably you are trying to resolve the exercises. Alexander, Laura?
Well, no, I actually don't have a particular question. I was just curious because also you advertised it so good and said it would be very nice. So
can you put your camera to see Markus, to see that?
Yeah, sure.
It's nice. Nice to meet you.
Thank
Hi.
you, Alexander, Laura. Thank
Nice
you.
to meet you.
Yeah, Alexander and Laura are our Erasmus students, and this is a very, for me, it's like a most challenging teaching class, because there are people that never programmed before. I'm so happy to see how a student without no previous knowledge in programming can resolve exercise like your Sudoku and can understand that in only 12 lessons, more or less, 2 hours, 24 hours. They start from totally zero, no idea in programming, never programmed before, to understand your code in the Sudoku, for example. So for me, it's like so great challenge every year with these Erasmus students. This year I have many good people working with, with that. So happy.
Nice. Yeah, I'm very pleased to hear this. Thank you also for coming. I hope, I hope you have fun with this. I have also seen a lot of progress, especially by absolute beginners who, I mean, it takes, you can make, I mean, this is also a danger, certainly. I've also seen people very promising, very fast progress, and then completely breaking down, completely collapsing, completely falling apart after maybe 3 months or so. So this is also a danger of overtraining, maybe one could say, or of going too quickly. I think, it's in my experience, maybe 6 months of use or so. After 6 months, you can then start to truly benefit from Prolog. In the first few weeks or months, you can make very fast progress. You can run. You can then solve all these also puzzles, interesting tasks, also timetabling and so on. But the true benefit will usually take at least 6 months of dedicated work, and after 6 months, you can truly start with meta interpreters, with programs that analyze and run other Prolog programs, and this is then where the true benefit comes from. And and if you go too fast to that stage, then I've seen all kinds of strange phenomena from beginners who were very promising at first. Also on the internet. I mean, I know them. I interacted with them. They began to solve quite advanced tasks, answer quite advanced questions, also very fast, and then collapsed completely, and then made the worst beginner problems and beginner errors again, fell down to the lowest level parts of Prolog, and then staying there exclusively. So this is, maybe it takes also some focus to really also work in the right part of the language, so to say, in the part that preserves these properties of logical reasoning, and in this pure monotonic part, it's called. And there you can apply these logical properties, and there you have the flexibility of, for example, interpreting the same program with different execution strategies. This only works if you retain these logical properties, and if you throw them away, if you ignore this, then you will not benefit from this, and then it becomes some unorganized some swamp where you never get out again.
Would be interesting to know how many times we need one person from totally zero, from zero to resolve Sudoku in, I don't know, in Java or Java or Python. I don't know, probably much more time.
Yes, that's certainly. I mean, that's certainly. So I mean, I know. As a beginner, it can all seem very tough, also, and some parts. Or also, if you know, especially some other programming languages, then Prolog can seem very hard. But the reason, I think, in my opinion, at least, is that you start also with much harder tasks. So, for example, the initial Java tasks, maybe implement some, I don't know, work with some array or some linked list. This is not an issue at all at Prolog. You simply write it down and it's there. So you start from a much harder base level already, where you suddenly solve complex, often family relationships or quite complex combinatorial tasks. No Java beginner could solve any of this, and these are tasks that are not given also to beginning Java or Python students, never. So with Prolog you start with tougher tasks, parsing, for example, already, and then it can seem also harder, certainly. And also, it's hard also to keep students, certainly, to make sure also as a student that you are on track in the right direction, so to say, that you are really benefiting the most from Prolog by staying to this monotonic core language, and not get lost in the parts that are maybe there for historical reasons, or for some other reasons.
Okay.
It's hard. It's
sorry.
Just maybe to add this, it's tough also from a didactic perspective, certainly, because if you show these parts, then they are known, then they will be more used. If you don't show them, then it looks like you don't have an opinion maybe on them, and then maybe someone finds it out from some book, or then it seems like these are equally good. So it's a tough balance also, whether you even show these tasks or discuss them, these parts of the language, or whether you simply leave it out entirely. It's tough. I also don't know which approach works best, or where this balance exactly is. Maybe there should also be some sense of showing also how not to do it. But it's a tough didactic question.
Okay. Thank you. Adrian, I want to ask you if you want to participate. You have any question? You have want to? Oh. Okay. To don't make that because I have, I don't know, 100 questions. I want to do many questions about the SWI Prolog, but I think we can have a meeting later. Probably I want to know what is the future, or what is what your vision about SWI Prolog. But before that, and not to do that so long, this week, one professor in my department talked about the white book in artificial intelligence in Europe.
Yes,
and
the white book, yes.
Yeah, and he talked about what is the situation now in the world about artificial intelligence. Like, there are news that United States and China are ahead in Europe. Europe is saying the back side of the research in artificial intelligence last time. Now it's like Europe want to react to this situation and put a lot of effort to improve, to make the companies more intelligent, or using this type. And for my students, or for the students, I want to know how this new effort in Europe can affect to the one person that are studying now, and what you recommend to the student to they can do to be in this new era of artificial intelligence in company. Europe probably putting a lot of money, a lot of effort to improve how they and the idea to apply artificial intelligence in all areas, in all aspects like agriculture, health, education, and many things. What do you think? Because our students are from many different areas. What you can recommend to do in this new era of artificial intelligence related to Prolog? What to do?
First of all, I posted the link to the white paper on artificial intelligence in the chat. It's here. You can download it if you're interested. So, I mean, maybe to discuss it head on. I mean, the question is not how can we catch on now, but what can you do so that you're ready where the others are moving. So you must be heading where the journey is going, not where everyone is now, because otherwise you will always only catch up. I mean, it's certainly a good political trick to go to the government and say, for example, oh, the other country is extremely far ahead. I certainly need funding for this project because we are falling behind. This was also applied in the 80s, where the US researchers went to their governments and said, the Japanese, they are extremely ahead, and they are now getting even further ahead. We need funding, certainly, and then, they also got their funding. So certainly it's also a political interest to state others are extremely far ahead. However, certainly some are ahead, but in Europe, the situation is also, I mean, we have a very strong educational system in Europe, strong universities where many of these ideas even originated and are taught. I mean, even I studied computational intelligence, so it's not called artificial intelligence, but very heavily statistics, logic-based curriculum was perfectly normal and was a perfect continuation of what was completely, I mean, well understood also in Vienna, because we had also in Austria, for example, great researchers, and also still have great researchers both in symbolic and in statistical approaches. So I think certainly you must have a well-founded base of the scientific landscape. So you should certainly know what's state of the art, state of the science currently, and then, I mean, there are so many issues to tackle where you can apply if you know these technologies. If you know, for example, programming languages that let you really reliably and easily automate things, this is in huge demand, as we see it currently almost everywhere during the pandemic, for example. Even basic questions like reliably ensuring these logistics, for example, that everyone has a reliable date, where they get a vaccine, where they can register. These are all rules also that must be applied, so that everything also must happen according to technical standards also that can, so for example, that you can still fly to a different European country, show that you are, for example, vaccinated, or that you have been tested. So this is a huge topic in Europe, especially because we are dispersed across Europe with different languages, with different cultures. We must have technical standards to meaningfully cooperate. And this is certainly also one important point of this white paper on artificial intelligence, that we have common standards, and this includes certainly standards for programming languages, so that we can easily exchange solutions, easily interoperate. And I think this will be an important topic for European cooperation in cyberspace, you could say. So cross-country reliable networks based on nice standardized programming languages and languages that allow to more quickly and more reliably build the necessary IT solutions.
You know, for example, a good place, a good master, because, for example, our students start at this point, they are a basic knowledge about Prolog. You know, a good place, master in logic programming that prepare to someone that is not from the field of computer science for other fields to be ready to apply artificial intelligence with logic programming techniques to the areas in agriculture. I don't know. Alexander, for example, I don't remember now. What is your nationality, your studies?
German, actually.
German. And you did?
I did a bachelor in economics, and now I'm doing a master in business analytics. Okay, perfect. Business. And Laura?
I'm German as well, and I did a bachelor in marketing research. Now I'm doing business analytics as well. Okay, business. But they are a student for other different fields. Like, you know, a place where if they want to improve, they can take, for example, in Austria or I don't know, another place.
Yeah, I post a link. I mean, especially German-speaking people are here at an advantage because there is this GUPU system by Ulrich Neumerkel. So this is my Prolog teacher. He runs a logic programming course at TU Wien. And I send you the link, paste the link in the chat. It's called GUPU. So this is a gesprächsunterstützende Programmierumgebung for the German-speaking participants. And this is a very advanced automated teaching environment for Prolog. So the way this works is, and this is not available publicly, but available if you take this course. This is an automated system that interacts with the student by having internally a reference implementation of these examples, and then also making statements about the student code based on conclusions that are drawn from the reference implementation, and also pinpointing, for example, and saying, this should not hold, but currently it holds with your program. So you must specialize the program. Or, for example, this doesn't hold, but should hold, you must generalize the program. So you learn to think in terms of specialization and generalization. And this is all automated. So this is one major attraction of the system. That's in principle, it's scalable because it doesn't require a single person. But currently, it's mostly available in German. I mean, there are French and English editions, but the German is the currently most up to date and includes all the latest developments also that are now available or becoming available in Scryer 6.0. But this is one thing I highly recommend. And we have a lot of great Prolog programmers in Austria due to this system who all took this specific course, and I highly recommend it. Includes also for specific tasks from industry, like CPU scheduling, DNA folding examples, grammars, all kinds of interesting, also bridge building examples, all taken from industrial applications. Yeah.
And you think it's possible to follow this course for people that have no previous knowledge in programming? Or
certainly. Yeah, this is certainly this is all documented. It comes with so you have to log in remotely into the system, and it has thousands of pages of documentation also that that's available. It has these automated explanations, so you can truly interact with the system, and you can always also internally there send a message to the instructor and have this personal response.
Nice.
So this is one for me. It's a huge motivation. I mean, one of my primary motivations to work, for example, on Scryer Prolog and on free Prolog systems in general, is to make a free Prolog system available that can run this Cupo system, because it's currently built on 6 Prolog. And my goal is to help these free implementations with all the necessary features so that they can at one day run Cupo.
I remember now, you told me last year that write to this professor to ask to access this system, but this time I want to be involved, and I'm thinking to make an stage, probably go, I don't know if possible, 1 or 2 months, go there and try, if it is possible, I don't know, and try to learn this methodology. Would be nice.
Yeah.
I don't know if I had the possibility to go, but now I have time.
Yes.
I have 6-7 months without classroom now, so
nice.
I have time to go, and
yes.
this is one of my ideas, that to improve, to learn this
nice
methodology will be good. I will ask you later about this option, probably to talk this professor.
This would be awesome. I mean, this would be great. Yeah, please, anytime. If you are also in Vienna, please let me know, and let's visit also Ulrich, who implements this system. He's the convener of the Prolog ISO standardization group. Also, he's a true expert, one of the foremost experts in the world about Prolog implementations. And the only one who teaches it with this automated approach, which he himself built. So this would be nice to see. It would be great, certainly.
I have the idea. I have to explore the options, but I have the idea to go there for some weeks.
Nice.
I don't know.
This would be perfect. Please let us know.
What do you think is we finish with? I don't know if I have one question. If you want to finish. Not do this conference so long, about, for example, SWI Prolog. What is the point? Is because now I had in my computer with Docker. It's not easy now. This moment to installing is not easy like SWI Prolog to install. Prolog, the version of Prolog we use now have this graphic debugger.
Yes,
and it's more easy. What do you think about SWI Prolog? What is the point now? How many times you think is needed to have a version with all the, I don't know, the most important question ready, or you think it's now ready?
No, it's not yet. I mean, SWI Prolog is one of the most interesting recent developments. It started a few years ago only. It's now, one could say, beginning still, because this is now just a few years. And currently, for example, has no garbage collection. So if you have a long-running tasks that generates terms, you will run out of memory in at some time. So the system needs, for example, a garbage collection so that you can run, because the interesting programs run without ever terminating. For example, if you want to find a proof of something which you don't know, or some counterexample or some conjecture, you start a program that tries to find something and then keep it running for maybe years or decades, as long as it takes. So you need a garbage collector that reclaims the memory that's no longer needed, because these terms are no longer referenced. So that's one thing. And also Mark Thom, the implement of SWI Prolog, Mark, is now working on a more compact internal representation of terms, so that it will also become much faster still. So this is currently really beginning. It's quite nice already. One can show some interesting things already. It has some libraries like library debug, but the key attraction already now of SWI Prolog is, and this is the first Prolog system that has it ever, is a very compact internal representation of strings. So a string is a list of characters, so 1 character atoms. And in all other Prolog systems, or in other Prolog systems before SWI Prolog, now some other systems are also adopting these new techniques. But in all other systems, instead of, for example, if you have an ASCII string, let's say A, B, C, D, that's just 4 atoms maybe, this is just for example, should be 4 bytes just. If you have ASCII, there should be 4 bytes in memory. But normal in Prolog, the atom A is not just 1 byte, but takes 8 bytes because it is one address into memory. And for an atom, it usually takes one so-called cell of memory. And the cell is not just 1 byte, but 8 bytes. So each of these 4 bytes it is already an 8-fold overhead on 64-bit systems, because one cell is 8 bytes on 64-bit systems. But not only that, but a list has a certain representation in Prolog where you have a functor. This is called a dot for a list. Dot, then the first element of the list, and then the tail of the list. So you have already to store this dot, you have again 8 bytes. So you have at least a 16-fold overhead, and probably even more, even a 24-fold overhead over the normal representation. One could use this just 4 bytes. And SWI Prolog is the first system ever to implement these lists of characters so compactly. And this means that for the first time ever, we can use now Prolog for the task it was intended, namely fast parsing of huge amounts of text. And this is now unique. This is a very exciting development in SWI Prolog. And now other Prolog systems are also already adopting this. And I hope that even more systems certainly provided in the future. And also the first system where characters are really now the default. So you can write the string simply using double quotes. You have double quote A, B, C, D, and it's a list of characters, which is nice, certainly, because you can now easily write these strings and have all conforming to the ISO standard and have this very compact internal representation. And yeah, this also, it's the first Prolog system written in RASP, which is a new systems programming and general purpose programming language with some very interesting properties. And I think this will be also a huge reliability benefit to use these guarantees that RASP provides regarding this memory safety, yeah, there's a huge, a very promising approach.
RASP.
Rust is Rust. No, it's called Rust. It's called Rust. This programming language. And I post just to make it clear what we're talking about is this link here to SWI Prolog. So yeah, this is just starting, and it currently for Windows you need this Docker file because there's some component that SWI Prolog uses. It's called this terminal crate, which is not available yet for Windows, but I hope will also become available in due time. It's also a quite recent development. Or with recent, I mean it's just in the last maybe 5 or 10 years or so, not even that. So we can expect this to be developed for 20 years maybe, assuming, and I hope, of course, that the author has this interest to continue with this work. But I invite you to contribute or take a look at the system or share it. And I hope some of you may also take a look at it and also find something interesting, for example, to contribute or to try it out. Would be nice, would be great, of course.
I think my last question. Your code needs a scribe, or for example, the timetable code only run in Scryer. It's not possible to run in SWI Prolog.
You can run it, but it requires certainly some changes. So in SWI Prolog, I have made some recent improvements to the constraint solver over finite domains. For example, this chain predicate, where I know now that I initially used the wrong argument order. So the first argument in chain should be the constraint, because so for example, you can have y, so chain should be the less y, because then you can have, for example, really such chain of chains where you map list chain. I posted here, where you have a list of chains. So and if the argument so you could add this, but it's a compatibility layer. But certainly I try to promote SWI Prolog due to its standards compliance. So it really conforms or aims for conformance to the ISO standard, which is a big plus to exchange Prolog applications, because then it's also not dependent on this single system, but you could, for example, switch another ISO conforming system. For example, in Sixus Prolog it would run.
Nice. Okay. Thank you so much.
Thank you
so much, Markus, Sergio, Laura, Alexander, Adrián. Thank you so much.
Yes, thank you so much. It was really interesting.
Thank you. I'm glad to hear that. Yes, thank you for attending. It was a pleasure, and I hope you have fun and interest. If you have any questions maybe that you remember later, just let me know anytime.
Yes, sure. Thank you so much. Sounds good.
Thanks, yeah.
You have your email in your webpage, you know?
Yes, it's in the webpage or in the programs. Or please just ask Jose.
Okay.
It's great.
Thank you so much, Markus. I always, for me, it's like a big surprise. I write you some days ago, only some days ago. After 1 year, I know you are a very busy person, many things to do. And you answered to me with this opportunity to have this video conference. And after that, I asked you for the option to have my students. And I'm only have to give you thanks for your time and your, I don't know how to say, disponibilidad. I don't know. I don't find the Spanish
You're
English
very,
word.
very welcome. It's a pleasure. It's a pleasure for me. I'm glad and really proud also to see that you're interested in this, and I hope you'll continue to find it useful. So take care, everyone. Thank you a lot. Have a great evening.
Yeah, the same for you. Thank you.
Bye.
Bye.
Hasta luego.